What's that? Ah. Already. Not a lot of lag. Thank you to the Friday Transportation Seminar. My name is Miguel Figliozzi. I'm in charge with Jennifer Deal and other colleagues in urban planning and civil for this Friday Transportation Seminar. And today, in the schedule, doesn't work? It's on.
Did you turn it on?
Yeah.
Okay.
It's on.
It was on and then it cut out after you went from the desk. So.
All right. You have me. We understand now.
Maybe starting again and see.
Yeah, so now we can go. So, welcome to the Friday seminar. We had some technical issues, but I guess now we're okay. So, if you look at the schedule, my name is there, but actually today Alex is going to be presenting. So, we have been involved with many people in civil engineering and environmental science. Linda George and Christine Kendrick from environmental science, and our colleagues in civil. We have 4 papers that we're trying to put together here in this one presentation. So it's going to be an overview, and because Alex has been involved in many of them and has done a lot of great work also, so he's going to be presenting today, and I'll be here too for questions if needed, but Alex is going to take the lead now. All right. And don't forget, if you ask questions, to press the button so the red light is on. All right. Thank you.
Okay. Great. Thanks, Miguel. I am a graduate student here. As you said, my name is Alex Bigazzi. Miguel's my advisor. And I want to make sure I give due credit because a lot of this research and even some of the slide content is created by some of my colleagues here, some of the other graduate students. And so, and you see them over on the far right. They've done a lot of research on the ground and collecting the data and data analysis. And here we're kind of trying to synthesize these 4 and see what lessons we can bring away. So the question we're looking at is reducing travelers' exposure to ultrafine particulate matter pollution. And we have a multimodal set of data here that we're going to overview. Perfect. So first start with a little bit of motivation about why we're looking at this fine particulate matter pollution, and then we'll have 4 case studies. We're going to look at freeway congestion, so for auto drivers, look at cycle track exposure, look at a sound wall or noise barrier next to a freeway, and look at exposure in a bike ped multi-use path there, and then finally look at bus shelters. And the last 3 have been touched on in previous presentations, so I'll spend less time on those. The freeway congestion one is fairly new results, so I'll spend a little bit more time describing those. All right, so there's a lot of interest right now in more sustainable transportation systems, and I'm not going to motivate that piece of it, but a part of that is reducing our emissions from the transportation system. And so there's a lot of interest in shifts to active transportation modes. And various studies have shown the potential health benefits through increased physical activity. There's also been some criticisms that perhaps there are health trade-offs involved, where you have increased physical activity, but some studies have shown increased exposure to an uptake of traffic-related pollution. And so part of the motivation for this research is looking at ways that we can make travel healthier, safer from a health perspective, make travel healthier for all road users, and especially interested in not just looking at the dominant mode, which is the auto, but also looking at the active transportation modes. So the questions are, what solutions can we look for to reduce exposure, and also can we measure exposure over time and see how we're doing? So particulate matter is a dangerous form of pollution. We're specifically today looking mostly at ultrafine particulate matter, which is kind of the smallest stuff. Right now, it's still not regulated in the United States, either from an ambient air quality or from emissions point of view, but it's a fairly new pollutant of interest, and it's being considered for inclusion in the new Euro automobile emission standards. And it has been shown in urban areas to be primarily caused by motor vehicle emissions, both primary emissions and secondary formation because of volatile gas emissions from the vehicles. And why we're concerned about particulate matter, because of its size, it has the ability to penetrate deep into our lungs and even enter our circulatory systems. And in addition, they tend to be highly reactive because there's a lot of surface area for chemical reactions to take place, and there are a lot of highly reactive compounds typically involved in ultrafine particulates. Now, past toxicological studies have shown links to various diseases, respiratory diseases especially, but also heart disease and cancer. The epidemiological evidence at this point is more scant, largely because of a lack of monitoring data. We have very little empirical UFP monitoring data that will allow us to have strong epidemiological evidence. But there are a few studies, a few long-term studies out at this point that show some tentative links to increased mortality and morbidity. So there appear to be some strong health effects of UFP. Now, when we're trying to estimate or assess UFP exposures, ultrafine particulate exposures in transportation environments, similar steps to other pollutants. First, we have to estimate the generation and then the dispersion so we can get to the UFP concentrations, and then finally we're looking at the uptake. And UFP have some special challenges in each one of these steps. In terms of generation of UFP, quite often a significant portion of the UFP generated are secondary formations, so you have volatile gases emitted at the tailpipe and then nucleation and formation of UFP after the initial gas emissions. So it's not quite as easy to extrapolate our laboratory tests from tailpipe emissions into what the real-world UFP are going to be. You also have some special challenges in terms of estimating exposure concentrations because UFP have distinct removal mechanisms in terms of agglomeration of larger particles where they move out of the ultrafine particle size range. So some special challenges there. In terms of the body of research that has been done, most previous UFP transportation studies have done modal comparisons, so they'll look at a typical commute, say what would happen in a car versus a bus versus on a bike. There are a lot fewer studies, and they've shown significant differences by mode, but a lot fewer studies that have looked at the travel in detail and looked at the traffic characteristics and the built environment characteristics around those trips, which limits our ability to both have accurate exposure measurements and develop mitigation strategies. So that's where we come in with this set of studies that I'm presenting today, is we're looking for, one, identify some simple, low-cost solutions to reduce UFP exposure for various mode users, transportation mode users. Also identifying the major factors influencing UFP in the transportation microenvironment. And then finally, just quantifying UFP levels for the Portland area so we can get kind of a baseline and see where we're going. So this is the first case study I'll talk about, looking at exposure for motorists in freeway congestion. This was data collected in the summer and fall of 2010 on Oregon 217. And we had about 15 hours of data collection. So we have in-vehicle air quality, we had outside vehicle air quality in a probe vehicle that was driving in mixed freeway traffic. And we also collected concurrent meteorology data, traffic data, as well as GPS data from our probe vehicle, and did a fair bit of analysis on that. We also had video, forward-facing video in the probe vehicle. And I won't go into too much details of the methodology, just kind of get to the upshots in terms of results. Now, in terms of congestion effects, we found almost no relationship between general congestion level and UFP exposure concentrations. So, and that's both inside and outside the vehicle. So in general, aggregate congestion was not associated with higher UFP levels for motorists. What we did find is a number of suspected high-emitting individual vehicles. And what we have here is an example trip. So the probe vehicle moved from right to left on the screen, and the height of these bars is the exposure concentrations, and the color is the speed of our probe vehicle. And you can see they encountered a fair bit of congestion here near the Beaverton City Center. It was a fairly steady UFP level. And then there was one high excursion here later in the trip where we still had fairly high speeds. And this was correlated with the passing of this diesel bus, Flanagan, I believe it was. And we found this in a number of cases where there were high excursions, high deviations in the UFP levels measured that were spatially and temporally correlated with a single vehicle. Now, we weren't able to measure those vehicle emissions directly, but it's a reasonable assumption that they are from this vehicle that was there at the time. And so while we didn't find aggregate traffic relationships with UFP levels, it did appear that a much more disaggregate traffic approach, looking at individual high-emitting vehicles, it has more explanatory power. In terms of in-vehicle versus out-vehicle concentrations, we found that the vehicle ventilation had the highest impact. And this was bigger than meteorological factors and also bigger than traffic-related factors. So what you have here is 4 sample trips, and the X's and dashed lines are measured outside vehicle UFP concentrations, and the colored circles are the inside vehicle UFP concentrations. Our top left figure is with the windows down, so you have a whole lot of ventilation. And you can see that the in-vehicle concentrations track closely with the outside vehicle concentrations. They're slightly lower, but very close. And the colors of the circles are the probe vehicle speed once again. And then on the top right corner, now we've rolled up the windows, but we kept the vent pulling in outside air. And you see a much lower in-vehicle UFP concentrations compared to outside. And on average, that was about a 50% reduction in UFP concentrations from rolling up the windows. Still clearly influenced by the outside concentrations, but much lower. Once we put the ventilation system on recirculation, so we're no longer pulling in outside air, we saw a dramatic reduction here, on average, an 83% reduction in UFP levels compared to the outside concentrations. Not only that, but it's much less responsive to changes in the outside UFP concentrations. And finally, on the bottom right, we have the windows up still, we're recirculating cabin air, and now we've turned on the air conditioning. And it's a slightly greater reduction in UFP concentrations. So vehicle ventilation appears to be a large impact and much larger than the traffic impacts for the motorist in congestion. So our conclusions from this case study, aggregate traffic impacts not so much, but targeting high-emitting vehicles appears to be a good mitigation strategy. In terms of much more everyday, low-cost mitigation strategies, simply rolling up your windows and switching your air vent to recirculation can dramatically reduce your exposure to fine particulate pollution. And an extension we'd like to pursue is a structural way to assess and identify high-emitting vehicles that we can target, because right now UFPs aren't tested. When you take your car to the DEQ, UFP is not one of the things they're looking at. Okay, so now I'm going to move into the second study, and like I said, I'll spend a little bit less time on these because some of you guys might have seen these results before. The next one we're going to look at is the cyclotrack research, and I think, like I said, I think some of you all might be aware of this, but downtown, the Broadway, we are downtown. Very near here, Broadway was converted from a bike lane to a cyclotrack. So here is the previous configuration with the bike lane between the travel lanes and the park lanes, and then they moved it over so it's between the parking lanes and the sidewalk. And so we're looking at the exposure effects of that change in roadway design. So the study design was similar. We collected UFP levels in the 2 areas of interest. So we collected them with respect to the parking lane on the motor vehicle side and on the cyclotrack side, and then collected concurrent traffic and meteorological data. And we did this for a series of AM and PM peak periods. And getting straight to the results, the cyclotrack did significantly lower UFP exposure for cyclists. It was much lower on the far side of the parking, as you could expect. We found about an 8 to 38% reduction in UFP levels. Now, there's still wide ranges in these UFP levels, and the same with the freeway. There's a lot of unexplained variability, that are related to changing traffic and especially changing meteorological conditions. But still, the effect of the cyclotrack was significant. And so what we found in terms of estimating exposure, small distances in the microenvironment, so small, even in a single roadway, small changes in distance can have a very large effect on your exposure. And so just swapping the position of the parking and the bicycle travel lane can really reduce our exposure. Now there's still some extensions we want to pursue, is looking at a wider range of bicycle facilities. And then, of course, this is not a blanket endorsement of cyclotracks as the safest with respect to air quality, because there's also plenty of other things you have to consider. But from a UFP exposure level, it is lower. All right. The third study was we were looking at a sound wall and the effects on UFP exposures in a bike ped multipath. So at various locations around the city, we have a bike ped pathway in a freeway right-of-way. And sometimes it's on the freeway side, and sometimes it's on the non-freeway side of the sound wall that's erected. So we're interested in the UFP effects of that. We looked at 2 locations, one out onto Highway 26 and then one out in southeast Portland on I-205. And at those 2 locations, similar study design, we measured UFP in the protected and unprotected locations. So on the freeway side and on the non-freeway side, concurrently measured those UFP. Along with, we had meteorological data, including wind data, temperature, humidity, and then we had traffic data from Portal, our transportation data archive, to get speeds and volumes on the freeway here. And again, jumping right into the results, we found, not a great shocker here, significant reductions in UFP when you're behind the wall versus in front of the wall. And here the reductions were in the range of 12 to 84%. Once again, there was a lot of variability. The sound wall certainly didn't explain all the variability, and we had fairly complex relationships with traffic conditions and meteorological conditions. One of the biggest factors here was the prevailing wind direction. For example, at the 26 study site, we were measuring concentrations south of the roadway. So as you expect, when the wind was from the north, the concentrations are much, much higher. And in terms of these conclusions this leads us to, pathway design does make a big difference. Right now, exposure pollution is not a consideration when building sound walls. But these results show that it could possibly be another objective of sound walls. In terms of mitigation, putting the path simply on the outside as opposed to the inside of the sound wall can significantly reduce pedestrian and bicyclist exposure on these paths. And also, if you have the flexibility, putting it on generally the upwind side of the freeway compared to the prevailing winds will also help reduce pollution. Some further considerations from this study, we want to look at the effects of vegetated walls, as sometimes sound walls are built out of basically tall, thick trees instead of just concrete walls, and some other design considerations looking at varying height and distance from the roadway. All right, the last piece of research I'm going to talk about is the bus stop shelter study. Adam Moore talked about this a few seminars ago. But he was looking at bus stop shelter orientation on Powell Boulevard. And here he was looking at bus stop shelters, so the enclosed shelters that face towards the road and away from the road. Again, a similar set of variables that we're measuring inside and outside shelter concentrations, so protected and unprotected, concurrent meteorology, traffic conditions, and he also obtained a fairly detailed set of bus data from TriMet. And the results from that study found large diurnal variations, much higher in the morning than the evening, as could be expected. Lower temperatures tend to be correlated with higher UFP levels because of secondary formation. Excuse me. He also found, in some instances, high correlations between UFP and the traffic volumes on the corridor, which is slightly different from what we found on the freeway. But part of that difference is going to be on the freeway we were in the traffic stream, whereas he was not. He was doing roadside measuring. And the upshot from an exposure point of view for the shelters facing the roadway, the UFP concentrations were actually 12% higher inside the shelter. And for the shelters facing away from the roadway, they were 22% lower inside the shelter than outside the shelter. So this small difference in terms of orientation of shelter design makes a big difference in terms of exposure. So conclusions, again, there's a lot of variability in UFP exposure concentrations. It can't all be explained with a set of measured variables. And we're also, or Adam is also still looking at integrating more of the detailed bus data to look at how changes in bus characteristics, age, and emissions filters, et cetera, affect UFP levels. But orientation of the bus stop shelter can significantly reduce exposure. So here's, once again, our simple mitigation strategy. And other design characteristics, such as placement before or after the intersection, there's certainly more to look at here in terms of reducing exposure with facility design. So bringing all 4 of these studies together, we put them, I kind of put them all on one side. So we had 5 study locations out here on Oregon 217, the 2 sound walls on 26 and 205, the bus stop shelter study on Powell Boulevard, and then the urban core cyclotrack exposure study. And here I aggregated all the mean data from, that's redundant, sorry. I averaged the data from the protected and unprotected locations at each site. And that's what you can see here. So the lighter green, the taller bar, in each case is the unprotected. So here it's outside of the vehicle. Here it's on the freeway side of the sound wall. Here it's on the traffic side of the parked cars. And here it's outside of the bus shelter. And then compare that with the lower, the dark green bars, and that's the protected side. So inside the vehicle with the windows up, it's the opposite for each one, away from the freeway. And what we see is, first of all, as you saw in each case study, large reductions with these fairly simple mitigation techniques, rolling up the windows, putting the path on the outside instead of the inside of the sound wall, et cetera. So fairly large reductions are possible. In general, don't look at this as a modal comparison, because there are a lot of differences besides simply the mode that you're in. For example, for the cyclotrack data, we would expect the concentrations in the cars, if you don't have the windows up, to be just as high as on the traffic side of the cyclotrack. And if you compare the concentrations across, you can generally see, as you might expect, in the urban core with the most vehicle activity, and then also with the street canyon effects that reduce dispersion, we had the highest overall concentrations. Also, the next highest was down on this urban arterial, Powell Boulevard, where we were measurements very close to the roadway again. Slightly low at our 2 freeway locations, further outside of the core, and also a little bit farther away from the road. And the lowest was down out here on Oregon 217. So in conclusion, everything I wanted to talk about today, there are definitely some simple approaches we can take to reducing pollution or pollution exposure in transportation environments. There are a lot of big challenges out there, but it's nice to see that there are a few simple things that we can do. That said, there's still a lot of questions. Heavy vehicles, diesel vehicles, are known to be a major source of primary UFPs, as well as buses, and we need to look at some of that in more detail. A key question is particle filters. Some of the coarser particulate matter, some of the larger particulate matter, it acts as, it basically allows the volatile gases to condense on those larger particulates, and so there's some potential trade-offs there. As you put on, say, a particle filter that reduces PM 2.5 or PM 10, you might increase the formation of UFP. So you might have a kind of a bounce back, a rebound effect in terms of particulate pollution when you take out the coarser particulates. And also, there's still a lot of questions related to uptake for the active transportation modes, cyclists and pedestrians. We don't have, although there are some studies looking at respiration rates, especially for UFP, there's still too little data looking at actual absorption into the bloodstream. So that's something that certainly needs more study on the health side. On our side, some of the future work we're going to take and extend this to, we're putting in a couple of permanent air quality monitoring stations on Powell Boulevard. And with that, we'll be able to get more long-term data, which will help with these exposure studies and can also help facilitate some epidemiological studies, which would be nice to get more evidence on the health side. It'll also allow us to do more assessment of performance. In particular, we're going to look at the new adaptive traffic signal system they're putting in, do kind of a before and after study there. And once we get this air quality data, we want to do some work on integrating it and archiving it with our other transportation data. And so the more environmental data that we have aligned with our transportation data, the easier it will be for us to consider environmental performance along with our more traditional traffic and transportation-related performance measures. And finally, as I mentioned before, we'd like to extend the bicycle exposure study to look at a number of different facilities and look at some trade-offs in terms of other route characteristics in exposure. With that, like I said, a lot of this was other people's research. I want to thank excuse me, I want to thank the City of Portland. The Traffic Signals Division was really helpful in providing data, I know especially on Powell Boulevard. I thank Peter and Willie from the city. And TriMet provided a lot of data as well. Steve Callis, Dave Kraut, and Curtis McCoy. A lot of funding from OTREC, the Oregon Transportation Research and Education Consortium. Portland State and also the Miller Foundation have been quite generous. And these are the professors, Miguel Figliozzi, my advisor. Dr. Linda George is in environmental science, and they've been PIs on various phases of this, along with Dr. Monsieur and Dr. Hare, who were in engineering as well. And then Adam, Christine, Eric, and Courtney did a lot of the data collection and analysis. So with that, I think I'll open up to some questions. I'll start up front here.
When you had that test car, there were 4 indications. You had the graph up there with 4, you had windows down, and then 3 different indications. With one of those, was that with the vent in the recirculation mode only?
Mm-hmm.
And that's the one on the top right?
No, so this is, so top left is windows down, top right is windows up but pulling in outside air. Bottom left is recirculating air. And then bottom right is so kind of like you're reading a book.
Yeah. Mm-hmm. Did you have one where the vent is just turned off, the fan is turned off?
So we kept the fan on medium to limit the number of factors in our analysis. But there have been a couple of other pieces of literature that have looked at more variables in terms of vehicle ventilation. And they found that having the fan on reduces exposure, reduces the internal UFP concentrations. And the reason that is because pulling the air through the circulation system, you get surface deposition inside. And some vehicles will filter the cabin air. But even vehicles that don't filter the cabin air, or vehicles with very inefficient cabin filters, were found to reduce UFP levels because that process of pulling the air through there, the UFP is deposited on the sides of the
It's interesting.
system.
I had a follow-up. There was a spike on your response, you said, on when you were approaching Tigard. And that was a vehicle going by that you passed, or it passed you?
That one passed us.
And that passed you, and do you know if it was diesel or a gasoline-powered vehicle?
I believe that is a diesel. That one was a diesel bus. So of the suspected high-emitting vehicles, most of them were not passenger vehicles, but they also weren't 18-wheelers. They were mostly heavy trucks, but single-unit trucks with ground-level tailpipes. And one of them was also a very large kind of customized passenger pickup, but very large, and one was actually there was one that was a sedan, and with that one we weren't quite as sure about that one, but there was an odor actually as well when that car went by. We were actually behind it; it was right in front of us. So you could smell some sulfur. So I think on that one the emissions control system was probably malfunctioning.
This specific one was.
This you can kind of see it. It's this Volkswagen bus looking thing.
Okay, thanks.
Yeah, sure. Dr. Dell, I think, yeah.
So more of an observation that maybe I'll try to turn into a question, or both you or Miguel can reflect on it. So before my current career, I worked in California as an air quality planner, both federal and regional level. And what strikes me about this whole line of what you're looking at, back in the early 70s when we started in this country sort of focusing on air quality, a lot of the focus from a transportation perspective was on carbon monoxide, which was a very small-scale hotspot type of pollutant. and made a lot of progress there, and then basically don't really pay much attention to CO anymore, and then started focusing more on ozone, which is a very regional scale problem, and came up with different solutions and approaches to that. And now to me, there's a lot of analogy between sort of this focus on ultrafine, which seems to be the scale is much different. You're looking at very small design type approaches and vehicle solutions as well. And so it's just sort of interesting seeing or contrasting that with and when you think about greenhouse gas emissions is also sort of a big scale type thing. And so I'm wondering, it seems like the solutions are different, and I'm wondering, maybe to turn it into a question, have you been seeing much attention from the implementation side of, what do we do about these types of problems that are very different than what we focused on recently?
Sure, I'll give that one a pass. That's a really good question and a good observation too. And it's been interesting because if looking at the last 10 years of emissions modeling, it's kind of split to the greenhouse gas side, which doesn't care where the emissions happen, and if it happens at the power plant or if it happens at the street level, it's the same. Versus the UFP side, and where as you say, it is very localized. These are fairly short-lived pollutants. I know the EPA has been more and more focused on hotspot analysis for PM, also for PM 2.5, and that was part of the move. They're trying to generate more accurate models that can look at traffic activity in a lot more detail. So the old generation of traffic models could only deal with kind of regional level planning because it was in response to the NACS type regional air quality problems. Although they were trying to address CO, but they didn't have models at that time. So now they're trying to get these really detailed models. And then there's also the researchers trying to incorporate really detailed traffic emissions models with street level dispersion modeling and some computational fluid dynamic models that get very complex, like the air quality equivalent of agent-based models on the travel demand side. So these are really tough to construct. And it's still at the point where there's an enormous amount of uncertainty in the models. And so I guess in response to that, I've seen very little done in terms of mitigation strategies actually put in. They're still kind of trying to assess what they would be. And for UFP, they're still trying to assess what the health impacts are. But it has motivated a fair bit of model development. Miguel, did you have anything to add?
So I think it's a great question, and I think one of the issues is that technology was way different in terms of air quality 20 years ago, and ultrafine, for example, was impossible to measure with something affordable. Maybe NASA was able to do it, but no one was able to kind of measure that kind of type of pollution. So I think one of the issues is like technologies now allowing us to measure things that we were not able to measure 15, 20 years ago. And I think there is also this kind of lagging effect in terms of to demonstrate like health implications, you need these long-term studies. And because the technology is new and recently people started to, to look at these things and find correlations and so on. So I think unfortunately, it's going to take some time to really prove some of these things. But the idea is the very small, very fine particles that are the hardest to measure are the ones that are really bad because they can get at the cell level and can have a much higher damage in terms of health impacts. So I think that's the other thing that it's a moving target, and it's kind of hard to know where we are because as technology moves on, and we are thinking about even buying better equipment that we were not able to buy like 2 years ago, for example, to look at the distribution of these small particles, not just how many there are, but also the distribution. So the final thing is like vehicles are changing a lot, and with catalytic converters and so on, and even with hybrid vehicles. Our colleague Linda was telling us the other day, like there was just a recent paper where maybe the on and off of the vehicles hybrid stopping and that cooling the engine for a little bit and then restarting could be bad in terms of very ultra fine particles. So even if things look great at the beginning, I don't want to be pessimistic, but it's hard to sometimes to know what things that seems that are better in terms of, and Alex mentioned the filter about PM and how that might have an effect on ultrafines. And there are a lot of things that we don't know yet and that we are trying to really understand better. And again, that could be the issue, that new technologies will bring new challenges, and maybe you need to have better equipment to find these correlations or to understand what is really happening. So I guess the idea is you can do things, but unless we can measure it and we can study it, it's very hard that we'll be able to understand how many variables or what variables are really impacting emissions and exposure, because ultimately we want to know how people are affected by this. So not to be discouraging, but just to mention that it's complicated.
Yeah. Thanks.
Well, I read that paper.
Could you remember to use the microphone? Thanks.
So that was my question, actually. I was wondering, because of the potential for hybrids to produce this ultrafine particulates, and then you mentioned heavy diesels, but I was under the impression that some of the lightweight diesels, like the Volkswagen TDIs, which you're starting to see on the market, also produce it.
Yeah.
So I was wondering if you expect that to maybe bring this issue like a little bit more to the forefront, because obviously we associate those vehicles as being like good for the environment when they get 48 miles to the gallon or whatever.
Right. Yeah, no, good question. And I didn't mean to say that light vehicles don't, because especially if really heavy accelerations and any heavy load on a gasoline vehicle can produce UFP exposure rates near to what the heavy diesel vehicles are doing. And at the same time, they also produce a lot of volatile gases too, which lead to secondary formation of UFP. So there are a lot of, all these vehicles are producing UFP, a certain amount, although overall it's the heavier vehicles that per vehicle have a disproportionate impact. But I'm sorry, did I not answer a part of your question? It was, okay, we're good. Yeah, like Miguel said, there are a lot of complications.
You had briefly touched on the comparison that could be explored on plant barriers versus concrete barriers, and I was wondering if there was some sort of correlation specifically with UFP with humidity or plant transpiration, or respiration rather. Could you speak to that? Yeah,
so I could say in general, UFP are correlated with lower temperatures because that increases the nucleation of the volatile gases, and then low temperatures are related with higher humidity rates, and so there's also a correlation there. So in general, higher humidity is correlated with higher levels of UFP. Now, we haven't looked at anything about vegetation, but I have seen a study in Europe. Actually, they were looking at the ability of roadside vegetation, and it proved, and what they saw, and this was, I can't remember exactly the range of particulate sizes, if it was fine and UFP or just, but it was the smaller particulate matter. They found more absorption from a plant barrier or attenuation from a plant barrier than a concrete barrier, and part of that being the increased surface area of the plants. I think Kirk. I believe the Netherlands was looking at that. If you wanted to, they did a fairly large project on roadside air quality a couple years ago.
You mentioned that weather was not a major factor at all, but I was curious, did you operate in quite different scenarios? So I'm specifically interested in if whether rain would capture some of the particles or not.
Yeah.
And,
So if I said that, I didn't mean to say that. Weather was a significant factor. I think what you might be referring to is in this study, the vehicle ventilation was a much bigger factor than weather. But weather is a factor, and like I said, higher UFP, not just in these studies, but in other ones, are associated with lower temperatures and higher humidity. And in terms of rain, so there have been, and we didn't have enough, in the Freeway study, we didn't have enough variability to test this separately from the other weather factors. But other research has shown that rain kind of has one of these counteracting effects where rain tends to wash out larger particles, so it does reduce UFP. It does reduce coarse particle concentrations, but it tends to increase UFP concentrations because then those coarse particles aren't there for the gases to condense on, and so the UFP nucleate into so the gases nucleate into new UFP. So rain tends to have higher UFP levels, but lower fine and coarse particulate levels. I think you're.
Do you guys ever correlate with or collaborate with any groups that do chemical analysis of your particles?
So we haven't done that. There have been some studies not integrated with transportation studies, but some independent, or not integrated with travel studies, but some independent analysis of UFP emissions, and they found it was. Are you wondering about composition of the particles?
Yeah, because I think, when people are talking about different types of cars and things, you might be able to correlate different types of automobiles with different chemical compositions.
Yeah, that is a factor. Particularly low sulfur fuel helps reduce UFP concentrations because the sulfates tend to form fine particles.
So is it soot in fine particles, or what is
so
fine?
It's primarily organic matter, so like black carbon is a major component, but there are also various trace metals that were in the gasoline or diesel fuel that are in the fuel that make it, and there's a lot of there's a lot of oxidated compounds that are mixed in there, but a lot of it is carbon. The soot, basically.
We have several web questions. I don't know if I'll get to them all, but one, and this first one I think perhaps just raises some future research that maybe you can let us know if people are already doing this or if you plan to. So during the presentation you mentioned how the street canyons downtown probably increase the particulate matter. So if higher density reduces vehicle travel, which should reduce emissions, could this offset the density of emissions in the higher density developments? And is this something to study? And then also, if you have, or if other people have looked at, the magnitude value of the health improvements that could be attained from some of these mitigation measures you've talked about.
Yeah, good question. So the first part is I might say at this point a classic question in terms of transportation and exposure is this question of density. And it reduces emissions, but it also brings people closer together. And I'd say at this point, certainly for UFP, we can't quantify the balance of that trade-off. So there could be some issues. It's the same thing with active transportation modes. You're reducing emissions with fewer automobile trips in aggregate emissions, but people are being more active in these polluted environments, so there could be some trade-offs there. I don't think we could say conclusively either way yet. In terms of the second part, I had an answer, but I'm blanking on it. What was it again?
So the health, what might
the quantifying
be the health?
Yeah. Like I said, the epidemiological evidence isn't at the point yet now where for UFP we can say what the change in overall morbidity or mortality rates would be. And even for much more studied pollutants, that's still a tough thing to quantify. It's a pretty tenuous dollar value. Thanks, though.
Alex, are there any municipalities either in the U.S. or abroad that are looking at UFP when siting their trails, or is this too new that they're not even looking at UFP where, in regard to should they put it on the, inside or outside of a barrier?
I personally am not aware of anyone who's used UFP in a design. Miguel? No. But it certainly could be out there, and if someone knows of someone, I'd like that anecdote. That would be fun to hear. But no.
I was going to ask if you could talk about the difficulties with targeting the high emission vehicles. I mean, it sounds like a really simple thing to do when you go get your emissions test to just add that onto the mix. But.
Sure. Well, right now there isn't any. There's no policy. There are no limits imposed in the U.S. So first you'd have to create a legal framework for that. But in terms of detection, UFP could be measured. It's slightly more. It's a newer technology, so it's slightly more expensive, but those could be installed at the DEQ stations. But right now, it would just be collecting data because there's no policy to get them off the street. And I think in general, I think in general they are associated with heavier diesel vehicles. So there would be an association with our other pollutants. So, but like I said, we weren't able to measure the other pollutants from these vehicles, so we're not sure that they're correlated yet. That's going to have to be future work. And I haven't seen anyone with a policy of targeting UFP high emitters yet.
Oh.
There was one question on the web, and I think some people find it counterintuitive, the issue about congestion and the lack of, not being reflected on the UFP levels. But maybe you can comment on the kind of the density and what we found in the.
Yeah. So, so when we're talking about traffic variables, now we were in the traffic stream. So, the fact that it wasn't correlated with congestion, there's a few factors there. One, higher speeds, you tend to have higher penetration of pollutants inside the vehicle because of pressure differentials, and so. You'd have more, and like wind tunnel studies and various and modeling studies have shown that you have more penetration of outside UFP. So that kind of would counteract if you'd expect higher emissions. I'm sorry, higher concentrations during congestion. Now, what we did find, I mean, there is a positive coefficient on that relationship, right? So higher volumes relate to higher UFP concentrations. But what we found was that it was more density, if you did the traffic density measure, so vehicles per unit length of roadway versus the volume measure. Because remember, from traffic flow theory, the volume passing one location is going to go down in heavy congestion because vehicles are queued upstream. So if you think about it in terms of that, the volume measures aren't really indicative of your short-term exposure levels. And so I guess an answer to the question is that the density is positively correlated, but there's other offsetting factors. So in congestion, you have less vehicle-induced turbulence, you have less intrusion of outside gases, and also one other thing to point out is that UFP compared to other pollutants tend to increase more with positive speeds. So higher speeds have higher levels of UFP emissions than lower speeds. That makes sense. Hopefully I answered. Anything else? Okay.
On the web. One had to do with dissipation. So after the traffic maybe is gone or there's a lot less, how long does it take for the pollutants to dissipate?
Oh, that.
Or do they?
Yeah, no. So the high concentrations coming out of the tailpipe, they're going to disperse. So we have just physical dispersal, and that's with the wind blowing, as you'd expect. The more wind, the more dispersion, and the less impediments to wind. So if the more open the space is, the more dispersion you're going to get. But then you also have these other mechanisms. So you have formation of UFP, and that can happen 5 meters up to a couple minutes after emissions of the volatile gases that they're nucleating and forming new UFP. At the same time, the UFP that are existing tend to be agglomerating, and so new gases are condensing on them, and they're forming larger particles. And if you're measuring UFP, they'll move out of your UFP size range, so they'll essentially disappear. So you have these you have dissipation, but you also have formation and removal mechanisms. These are hard to separate, and we certainly couldn't separate these effects in this study. But in terms of distance studies, have shown an influence of traffic on UFP up to about 300 meters away from a roadway, and that varies based on the roadway and based on the topography. But certainly up to 50 meters, you can measure roadway-generated UFP. Sometimes as far as out to 500 meters, you can measure it. Just
to sort of piggyback on the size question, you had a great image in there of someone cycling with a dust mask. I know it's obviously beyond your scope, but is that completely useless? Is that doing anything at all?
Good question. So that actually, that's my girlfriend. In December, we cycled through the plume of the Chilean volcano, and we were wearing these dust masks. And the reason we did that is because that was mostly coarse particulate, and so most naturally occurring particulate like that, dust and stuff, is coarse particulate PM10. And these dust masks capture some of that PM10. There was less dirt in our mouths when we wore the masks, and I was really glad to have them. In that case, for UFP, they're not going to do anything at all.
Any last questions? Oh, yeah.
Just a good graphic.
Well, just a quick question. You've noted a lot about heavy-duty diesels and whatnot out there, but have you guys ever looked into maybe studying the ultrafine particulate matters out of, say, propane-powered vehicles, natural gas-powered vehicles, or even differing biofuel blends or green fuel? Or
Yeah, good question. I haven't, and I've only seen gas and traditional diesel comparisons so far. I've seen some biodiesel comparisons for other pollutants that showed a mixed bag effects where some pollutants go up, some pollutants go down with biodiesel. But I didn't see UFP in any of those, and I haven't seen anything with propane or benzene. So that's a good question and potential for future work. A lot of questions, a lot of questions.
Excellent questions. Well, thank you very much, Alex.
Thank you. Thank you all.